Alright, today we're talking about section 6-7 and we are graphing inequalities in two variables. And graphing inequalities is very similar to graphing equations, so you might want to review graphing just regular equations before you move on to this section. Very first thing we're going to talk about, vocabulary. Okay, when you're graphing an inequality, you're going to end up with a boundary line. Okay, and boundary line can either be solid or dotted, and we'll talk about that later. But your boundary line will split your coordinate plane into two different sections, and each section is called a half plane. Okay, so the boundary line cuts the coordinate plane into two half planes. Okay, there are some steps for graphing inequalities, and I'm going to run through these steps before we try any examples. Step number 1, you want to always rewrite the inequality in slope-intercept form. Okay, so we want to isolate y, and we want to identify what our slope is and what our y-intercept is. Okay, so that's the information we're going to graph. But before we graph it, we want to also, number 2, identify what type of boundary we have. Okay, there are two types of boundaries when you're looking at an inequality. The very first one, your boundary line could be a dotted line, and in which case you'll be using the symbols either less than or greater than. If you see any of these symbols, you know it's going to be a dotted line. And this is very similar to the open circle concept when you're graphing on just a number line. Okay, so the other boundary type is a solid line. And this is the case when you have less than or equal to, or greater than or equal to, or even equal to. Okay. So once you know what type of boundary line you're going to have, you know your slope, you know your intercept, you can go ahead and graph that. Okay, and after you graph it, the very last step, before you finish, you have to test points and shade. Okay, so these are the 3 steps for graphing inequalities. Let's do an example. Example number 1, we're going to graph this inequality. 2y minus 4x is greater than 6. Okay, so same steps that we had talked about. First thing I'm going to do, 2y minus 4x is greater than 6. Let's add 4x on both sides. 2y is greater than 4x plus 6. I'm going to divide by 2. Y will be greater than 2x plus 3. So now let's identify our slope, 2 or 2 over 1, and our y-intercept here will be 0, positive 3. Okay, so we said this was our first step. Y-intercept form, here's our slope, here's our y-intercept. Okay, so now we need step number 2. What type of boundary line is this? Okay, we see that it is a greater than symbol, so this means that we're going to be using a dotted line. Dotted line, okay, so make sure that when you're graphing with a dotted line. What you can also do is graph, if you're using a pencil, graph a solid line, and then go back and erase sections to make it dotted, okay? So let me draw a graph quickly. I'm just sketching this on paper, but if you have graph paper or if you have a stamp, you can go ahead and use that. Okay, our y-intercept is 3, so 1, 2, 3. Here's the point. Our slope is 2 over 1, so I'm going to go up 2 and over 1. Okay, so from here, I don't have a ruler on me, so I'm just going to estimate, but this is, remember, using a dotted line, roughly what your graph should look like. Okay, so this is the graph of y is greater than 2x plus 3. Now this does not complete your graph because we have one more step. Okay, so the last step we said we are going to test points. Okay, and we're going to test points on both sides of the plane. Okay, so let me try to squeeze that in here. Okay, I know that this point here, and I'm picking this point on purpose because it's a nice easy point, 0, 0, is on the right side. Okay, and we'll call it the right side of the coordinate plane. So what we're going to do is we're going to plug in, or we're going to substitute those values, x, y, into our original inequality. Okay, the original inequality is this. So we're going to plug in 0 for y, 0 for x, and what we're testing for is to see if this is a possible solution, if this would make this inequality a true statement. So 0 times any number is 0, 0 minus 0 is 0, so 0 is greater than 6. Is 0 greater than 6? Absolutely not. This is false. Okay, so when it is false, it is not something that you would shade. Okay, so what this tells you is that you're going to be shading on the other side of the plane. Okay, so all of your solutions should be on this side, the shaded side of the plane. And just to be certain, what we're going to do is we're going to pick a point that falls on this side. Okay, I know that this is 0, 3, so 0, 4 must fall in that plane. So let's test 0, 4. Okay, so here is 0, 4, and the x value is 0, the y value is 4, so let's plug that in and see what happens. So 2 times 4 minus 4 times 0 is greater than 6. This is what we're testing. So 8 minus 0 is greater than 6. 8 is greater than 6. That is true. Okay? If it is true, it should be shaded. Okay? Always test on both sides of the coordinate plane, both half planes, to make sure that you're shading in the right areas. Okay? And this here, with the shading, will complete your graph of the inequality. Okay? So what I'd like for you to try right now is, let's see, textbook page 337. You're going to try numbers 1, 3, and 5. Okay, textbook page 137, number 1, 3, and 5. Okay. We are going to try now a second example. Okay. And the second example is a word problem. For your 14th birthday, you're going to be given a budget of $120 to take a group ice skating. Okay, and we're going to write and graph an inequality for this solution, for this situation. So you're going to see how many adults you can bring, how many students you can bring. Okay. So first things first, we always have to define our variable. Okay. And in this case, there are adult tickets and there are student tickets, which means there are adults that can go with you or there are students that can go with you. Okay, and we don't know how many of each. So what I'm going to do is I'm just going to let x equal the number of adults. Okay, and we'll let y equal the number of students. Okay, remember sometimes even if you're a student, you don't have your student ID, you have to pay adult price tickets. So we'll see how many of each you can bring to your party. Okay, let's write our inequality now. We know that the number of adults, I don't know how many that will be, would have to pay $12 each, so 12 times x. Okay, and the number of students, I don't know how many are coming, but they're paying each $8. And if we add this together, this is how much you would have to pay for the entrance. And you only have a budget of $120, so you can't go over that budget. You can meet that budget, or you can go under that budget, so less than or equal to, or else you're not going to have enough money. Okay, so here we have written our inequality. Okay, to solve and graph, we're going to follow those same steps. So what I'm going to do is number 3. Let's solve this inequality. Let's subtract by 12x, subtract by 12x. 8y will be less than or equal to negative 12x plus 120. Okay, dividing by 8. Y will be less than or equal to a negative, and that's 12 eighths reduced to 3 halves x plus 8 goes into 120. Let's see, there's 15 times. Okay, so here's our equation, or our inequality. We have a slope of negative 3 halves, and we have our y-intercept at 0, 15. Okay, the next step, and this is kind of like a mini step, I always put consider your domain and your range. Okay, and quickly, in case you've forgotten, your domain are your possible x values. It's really important to do this when you're talking about a word problem, because it really dictates how you're going to set up your graph. Okay, possible x values. What does x mean in this problem? If we go back, x means the number of adults. Okay, number of adults. So we know that, well, at the minimum, you don't have to have any adults with you. Okay, so you can say 0 adults. Okay, and what would be the max amount of adults you can have? Let's see, let's look at our equation. If no students come, so we can block out that 8y, you can see that if no students come, you can bring 10 adults with you. Okay, so your x values from 0 to 10. Notice you don't have any negative numbers because you can't bring negative adults. Okay, and we're going to do the same thing for your range. Range are all the possible y values. Okay, and all the possible y values, we're going to do the opposite. Let's say no adults come. How many possible students can you come? It might just be a group of you and your friends. So 120 divided by 8, you might have anywhere between 0 to 15 of your friends. Okay, so when you graph, when you set up your graph, it's really important you have this information so you can set it up in a reasonable way. Okay, so let's see. Step 5, let's graph. Okay, here are our x values, and x values is number of adults. I'm going to write this to remind us of what that means. Y values, number of students. Okay, and again, looking at our domain and our range, our domain goes from 0 to 10, so you only have to number from 1, 2, 4, 5, 6, 7, 8, 9, and 10. Okay, and then our y values go up to 15. So here, let's see, 1, 2, 3, 4, 5, 6, 7, 9, 10. And you can go, instead of going by 1, I think I'll go by 2, 4, 6, 8, 10, 12, 13, whoops, 14, 16. Okay, so let's review some important information. We know that our y-intercept is 0, 15. So let's make a point at 0, 15. Okay, 0, 15. Let's remember again the max number of students or friends you can bring without any adults. Okay, and then we have our slope from here, so our slope is -3, 2. Okay, remember our slope equals -3, 2. -3 represents the rise, which means up or down, and 2 represents a run back and forth. And I'm going to write this just to be very careful because I have scaled this by different amounts. On the bottom my scale is by 1, along the side it's by 2, so I have to be very careful. Okay, so I'm going to go down 3 units, so going from 15 to 14 to 13 to 12. Okay, so that's 3 units. And then I'm going to move over to the right 2. So here's 2, I'm going to line it up, 2, 12 is a point. Okay, so I also know that at the max I can have 10 adults. So my line should, if I used a ruler, should stretch here. Okay, and notice that I made a solid line. Okay, the reason why I made a solid line is that you have to check your boundary types. Okay, the equation or the inequality has a less than or equal to symbol, so it is a solid line. Okay, so thinking about what areas you should shade in, we can always test points to see. Okay, let's rewrite our original inequality. 12x plus 8y is less than or equal to 120. Okay, my favorite point, 0, 0. Let's plug that in. Plus 8 times 0 is less than or equal to 120. 0 is less than or equal to 120. This is true. So that means I will be shading in, whoops. Okay, is that a possible point? Absolutely. What that means at this point is that no adults, no students, of course you're going to be under budget, okay, or within your budget. Notice that I didn't shade in any negative points because it doesn't really make sense, okay? We're not even talking about the negative side of the coordinate plane in this case, okay? And let's test a point outside that plane just to make sure, okay? So let's test, let's see. I can test 4, this is 4, 16. Okay, remember x comma y. Let's test that. So 12 times 4 plus 8 times 16 is less than or equal to 120. I already know that this is not going to be false. I mean, this isn't going to be true. I have 48 plus 8, 128 is less than 120. That's false. Okay, so there you go. You have your inequality graphed. Okay, so make sure at the very end that you try these problems in your textbook. Bring them back tomorrow and we'll talk about them. Thank you.